Good morning, everyone. Welcome to the second webinar under the Improval project. Today, the talk will be about the CE marking of electronics, and it will be presented by Professor Davy Pissoort from the KU Leuven, from the campus Ostende. So, please, Davy, go ahead.
Okay, thank you, Bart, for your kind introduction, and also from my side, welcome to everyone on this seminar on CE marking of electronics. My name is Davy Pissoort. I'm indeed from the KU Leuven Technology Campus in Ostende. I'm still based there, but from September on, I will be based at our brand new campus in Bruges. So this seminar is the second webinar in the framework of the Improval project, where Improval stands for Intelligence Products with a Predictable Lifetime. It's a WIS directory funded by the Agency for Innovation and Entrepreneurship, previously the IWT. And it's a collaboration between IMEC, the EDM group, CIRIS, and my own research group, Reliability, Mechatronics and ICT of KU Leuven. As a project, Improval aims at evaluating potential reliability risks and predicting the lifetime of electronics at the very early design states. And it does this based on three pillars. First pillar is the risk assessment and lifetime prediction tools. Second pillar is design and qualification guidelines. And the third pillar is an integrated reliability by design methodology. At the end of my presentation, you will get more contact details if you want to have more information about this project. So let's get started with the actual webinar. This is an overview of my talk of today. In the first part, I will be explaining a little bit about the history and the aim of CE marking. Why do we do CE marking? Why did Europe start up that CE marking? In the second part of my presentation, I will be talking about the difference between directives and standards. From my experience, I know that people quite often mix those two terminologies with each other, but for a proper understanding of the CE marking, it's quite important that you understand the difference between both of them and their role in the complete CE marking process. In the third part of my presentation, I'll be detailing the different steps you need to take before you can put a CE mark onto your product and bring your product onto the market. And in the final part of my presentation, I will be explaining this with the example of the EMC directive, where EMC stands for electromagnetic compatibility, which is one of my key expertise areas. So let's get started with the first section of my talk. What is CE marking? And why do we do that? Well, it all has to do with the European single market. So let's say a few decades ago, the situation in Europe was like that every manufacturer, before he had to or could bring a product into the market, was obliged to fulfill rules, but these rules were slightly different in every country. So if you wanted to bring a product onto the market in Belgium, you had to fulfill rules in Belgium, you had to create a complete test report in Belgium, and then it was okay to bring your product onto the market in Belgium, but if you wanted to do that then in France, you had to redo the whole process, do a little bit different tests, and get actually test reports that was valid for France, and so on. So that's clearly not coherent with the idea of the European single market. So Europe started with the objective to remove barriers to trade throughout the European Economic Area, thereby allowing companies to have free access to markets in all the different countries without having to meet particular local requirements in every country. And then in the period up to '92, and also still after that, the European Parliament has taken several measures, several actions with the intention to put the single market effectively into practice. So the outcome was an European Economic Area-wide legislation that all products have to meet before they can be put onto the market. And the end result of that that process was actually the CE marking, where CE marking is a process that applies to a wide variety of products, and which is a process that all manufacturers located in EU or importers of goods into the EU must complete. If you would wonder what CE is the abbreviation for, it's that of Conformité Européenne, so it's a French word, and English is European Conformity. And the CE mark itself should be fixed to the product before you put it into the market, but that's only the final stage of the whole process. And when you put it there, it's effectively a statement from the manufacturer or importer that the whole process to come to that CE marking has been successfully completed, and that the product indeed meets all essential requirements of all relevant EU regulations. And when it's put there, the CE marking as a symbol of free marketability in the European Economic Area, so it just means that that product can be freely transported and be put on the market in the whole European Economic Area. Okay. Like I mentioned, the CE marking on its own, when you put that onto your product, it's only the last part in the whole process. And actually the CE mark on its own is of no real value because it always has to be linked to, at one hand, a signed declaration of conformity. I'll be explaining that in more detail in the next slides. And also a quite extensive technical documentation file, where you actually give all the proofs, all the reasonings behind the fact that you say, well, my product fulfills all essential requirements related to the legislation with respect to the CE marking. And both those documents have to be kept in the community. You have to make sure that you can give them if asked for, and that for 10 years after that the product has been on the market. And here I interpret that sentence after that the product has been on the market, not from starting the first day that you put it on the market, but actually starting from the last day that it was actually sold. Within my research group, we do quite a lot of services towards industry, and one of those is that we do, for example, EMC testing, but also guide people in getting that CE mark on their product. And then I quite often get the question, well, I have this or that product, it's for that or that application, what do I have to follow? How should my declaration of conformity look like? What are the things that I have to look at? And then I always give the advice, well, just take Google and look up a few declaration of conformities of products that are more or less similar to the product that you have. And also for this presentation, to give you an overview how a declaration of conformity should look like, I've just looked up a few declaration of conformities and I'll be going through those in more detail. So here's the first example. It's an example of a typical router. It's a Juniper CDP 150, and you see the full declaration of conformity at the right of this slide. But we'll go through the specific items in this declaration in conformity in more detail in the next slide. So what is the first thing that you see in a declaration of conformity? Well, it's a description of the product. You see here that this is declaration of conformity for that CDP 150. And then you also see a description and contact details of the manufacturer. So here you see that this product is from Juniper Networks in the USA. We'll come back to what actually a manufacturer is, but you will also see that manufacturer, or the one that can get the contact details, can also be an importer or a legislative representative of the actual manufacturer. So that the terminology manufacturer is quite broad here. And then important part, of course, in declaration of conformity is to what is conformity claimed. And here you see already some terms here. You see there low voltage directive, you see EMC directive, RNTTE directive. And what you already see is that there's no conformity claimed as such to a standard, but it's conformity to a directive. And from there, I want to explain later on the difference between a directive and a standard. And then you indeed see some other numbers more below, where one says that to prove that conformity, one has applied harmonized standards. So here you do see the word standards, but I'll have to explain to you later what harmonized means. And there you see a number of standards that have been used. And then in the end, last part of declaration of conformity is a signature of an authorized person. You see here that the compliance manager of this company has signed this declaration of conformity, And here you have to realize that this is not only a signature for the company as such, but it's also a personal statement from this person. So you also sign this, your personal name, that you declare that everything has been done and that everything what's stated in this Declaration of Conformity is indeed true and can be proven through technical documentation. Second example, smartwatch, very similar. You see here the manufacturer, company from Taiwan in this case, product name, model name, so description of product and manufacturer. The undersigned declares this. And here you see a whole list of directives that one could apply with. You see EMC directive, RNTT directive, LVD directive, ERP, ROH, and actually the CE marking. And then what you see here, and again, quite important to understand the difference between directives and standards, is that for every directive there's a whole list, quite extensive list of possible standards. It's all the weird numbers that you see there, but only a few are selected apparently for this product. So this is also something that I want to explain to you, why for some products you use those standards, for other products you use other standards, while it's still for the same directive. And then again, in the end, finishing the Declaration of Conformity with the signature of an authorized person. So, as I've already mentioned, and like we've seen in the example of the Declaration of Conformity, there's a quite important difference between directives and standards. So let's go into more detail about that. Well, the whole European legislation related to CE marking comprises directives and standards. And like I mentioned a few times, for CE marking, it's very important to understand the difference between them. So let's start with telling what a directive is. A directive actually has the legal status of a law at the European level, and it's been approved by the European Parliament. So that's really the thing that you have to comply with. But it's a little bit a special law in that sense that it states that you have to achieve a particular result, but it doesn't really say or really dictate how you should achieve that result. So if you look at the EMC directive, which we'll talk in more detail about it at the end of the presentation, the particular result is that you should be free of electromagnetic interference. The results of electromagnetic interference, but how you should prove that or how you should do that is actually not in the directive. It's a law that is being made at the European level and is then transposed into national laws, and they only describe the essential requirements that you should comply with. So why is that? Why doesn't it really state very hard things that you have to comply with? So there's no numbers in it. Why is that? Because making a law and going through the whole process at the European level is quite an extensive and long process. And of course, we're talking about technological things here which are going very fast, and you don't want to go through the process of having to change a law every couple of months. No, you want to have a law, a directive that is applicable for many, many years. So if you will see later on in directives, you will see that they are quite old. So they last there a long time while technology is moving forward, and that's what one wanted to keep apart. So you really make very generic essential requirements which can stand there for a quite long time, so that you don't have to go through that process very often. Here are just a few examples of directives that might be applicable to electronics. So you see here active implantable medical devices, the EMC directive, which has a new version in 2016. So if you just see here, first version was in 2000, or the second version of the EMC directive was in 2004. That has been there for more than 12 years actually. Low voltage equipment directive, machine safety directive, medical devices, radio and telecommunications terminal equipment, which has been changed last year by the radio equipment directive. There you do see a little bit different of the scope. But again, you see radio and telecommunications terminal equipment directive has been there from 1999 until 2016, so almost 17 years. Toy safety, restriction of use of certain hazardous substances, ROHS. So this is just a few examples of directives that might be applicable to electronics. So we've already explained what a directive is, so that's the actual law. And then the question is, what is a standard? Well, a standard is then a document that really describes numbers and techniques to prove that you fulfill part of the essential requirements of a given directive. So it gives limits, it gives test or measurement methods. And then if you think back about those declaration of conformities, you saw there that one had applied harmonized standards. And what is a harmonized standard? It's just a particular form of standards which has been approved by European Parliament, which actually been published, just the title and the number, in the European Journal. So they have technical requirements that you can use to comply with essential requirements of one directive, the one that they refer to, has been transposed again to a national set of standards, typically only translation. And if you follow that harmonized standard, or either for the full essential requirements for a part of it, you get the presumption of compliance. And what this actually means is it means that from a legal point of view, one will say that you really comply with that essential requirements of that directive. So if there would be a complaint about your product and you have in your technical documentation, you can really prove that you have followed all the full harmonized standard in all its details as it is being prescribed, then you get the presumption of compliance, which basically means that one would say in court that you've done everything you should have done to fulfill the essential requirements or the part of essential requirements that the harmonized standard is relating to. Does it really mean that in every case you comply with the essential requirements? No. As we'll also see with the EMC directive, for example, the standards that are related to electromagnetic compatibility, they can never cover all possible situations of electromagnetic interference in practice. So there might always be some electromagnetic interference, which means that in reality you don't fulfill the essential requirements of the EMC directive, but you still get that presumption of compliance because you've done everything that you could do given the current state of the art to fulfill those essential requirements. It's a little bit perhaps a difficult thing to understand, but it's quite important to understand that what you actually do get is presumption of compliance, and you can actually never really hard prove, or very often not hard prove, that you will always comply. So which steps do we need to take to get to the CE marking? For that we have to understand a little bit about the history. So Europe started up already quite a long time ago, the global and new approach. And what does this mean? Well, global means, like I was telling about the European single market, that we have a legislation and a process, a way of working that is recognized by all countries in the European Economic Area. So you have to do the same thing in every country, and if you do it in one country, it's recognized by all other countries from the European Economic Area. What does new mean? That means that one has put the full responsibility by the manufacturer or the legal representative to actually go through this whole process. So they say that the manufacturer is the person that knows the product the best, and he's the best man to actually do the whole process and to make the assessment of the CE marking. Excuse me. More recently, one has put into practice the new legislative framework, where one has to try to get more coherence between the different directives. So terminology, way of working between different directives was a little bit different sometimes. So one wanted to make sure that everything was more aligned, and that's still a process that is going on. And for example, the review of the EMC directive and the radio equipment directive is something that's you have to see in this new legislative framework. And what is also added there is more generic policy on market surveillance. So what one aims with that is that one wants to try to avoid that products are being put onto the market that are actually non-compliant. So there are more ways to see whether or not the product complies with the CE marking. And then, how should you prove conformity with the European rules? Well, as you see there, it's new. One puts the full responsibility by the manufacturer, and one actually allows for most of the cases self-declaration. So the manufacturer himself can do the full process. He doesn't have to involve a third party if he doesn't want to. He can do that all by himself. But he has to put together the technical documentation, he has to sign the Declaration of Conformity, and he has to bring the CE marking on his product. The only case where it's not allowed is for products which have really a safety issue, where there are quite high risks if something goes wrong. Of course, for every time, even if self-declaration is allowed, you can always include a notified body and collaborate with them to get your CE marking done. If you want to get more documentation about this whole process, I can refer you to those two documents. So you can easily find the full guide from Europe on the directives and on the new and global approach. And there's also a very interesting white paper of Ahoria, which was sent to me by Mark Kums on CE marking, both available in Dutch as in French, where they actually explain more about the different roles within the new legislative framework. You will also find in that document a whole overview of all applicable directives to electronics. Just a few items that I've picked from that guidance document from Europe. So here you see what the new approach is based on. It's harmonization is limited to the essential requirements. So basically stating that the directive itself only gives essential requirements. You have to fulfill those essential requirements before you can put your product onto the market. And then to prove that you fulfill those essential requirements, you can use harmonized standards. And then if you use harmonized standards, you are presumed to conform to the corresponding essential requirements. But that's not the only way that you can use. So there's also other means that you can use. For many products, there are no harmonized standards. So then you, of course, have to do something else. So a manufacturer is actually free to choose any of the technical solutions that they believe that provide compliance with the essential requirements. Of course, if you don't follow a harmonized standard, you don't get immediately the presumption of compliance. And if you then would go to, in that case, there would be a complaint. And then you really have to explain, you have to explain in detail your technical documentation and explain why you believe that in that way you comply with the essential requirements. And as said, you're free to choose between the different ways to do that. Placing on the market is putting the product for the first time available in the community. Putting into service is the first use, and of course you have to comply to that product before it's placed to the market. There are a few exceptions, like well, if you would have a prototype that you want to show for the first time but not really sell immediately, there are some exceptions. You'll have to look into more detail about this in the document. And then, of course, and this is the whole idea behind the CE marking, all member states have to allow products that comply with the directives. They have to allow them onto their market, and they also have to do that market surveillance. So if they see that the product is put onto the market and it's not complying, it seems to not be complying to the directives, they have to take measures to make sure that that is corrected or that the product is actually taken off the market. So then what do you actually have to do when you want to come to a CE marking? Well, the first step is that you have to identify the applicable directives and regulations to your product and application. Once you know that, you have to identify standards that are applicable. Are there any harmonized standards that apply for part of the essential requirement? Then it's of course preferred that you use those. Once you've identified the standards, you will do testing according to those standards. Those test reports will actually be part of your technical file, proving that you satisfy all requirements related to the applicable directives. You write and sign the Declaration of Conformity. Based on that, you can apply, you can put the CE mark onto your product, and you can bring your product onto the market. So these are actually the different steps that you need to take to come to the CE marking and to do your conformity assessment. let's go into a little bit more detail about what should be in that technical documentation. Well, the technical documentation should have everything to understand what the product is and to understand why you say that you have that, why you claim compliance to the different directives. So a general description of the product or equipment, design and manufacture drawings, components, subassembly circuits, and so on. Explanations to understand all those drawings and to understand the operation and application of the equipment. Then your whole reasoning behind the risk assessment related to the applicable directives. And then a list of standards that are used. And when you don't use standards or use other solutions, you have to describe those solutions and explain why you believe that those are sufficient to meet the essential requirements of the applicable directives. And then, of course, you add test reports to that if you have done some calculations saying, well, can never be above that or that limit just because of that physics principle. You also add to that to the technical documentation. If you have, for example, a checklist that you use on your products, you add that to your technical documentation. So everything that you can use to prove that indeed you comply to that product. As being said, you have to keep this documentation available into community for 10 years, and you have to be able to give them within a very short time if being asked for. Then the Declaration of Conformity, we've seen a couple of examples of that. So name and address of the manufacturer or authorized representative, description of the product equipment, reference to applicable directives, reference to harmonized standards or other specifications when harmonized standards were not followed, who has signed it, so identification of the empowered signatory, and it has to be in one of the official languages of the community. And again, this documentation has to be kept in the community for 10 years and has to be made available if asked for. Now, also within the new legislative framework, one puts more focus on the fact that all economic operators from the whole supply chain are actually involved in this CE marking process. So let's go a little bit through the different definitions. So a manufacturer, what is that? It's actually any natural or legal person who designs, manufactures, or let design manufacture a product with a view to placing it onto the community market under its own name or trademark. So here you can see that manufacturer is not only the one who really makes it, but can also be that you think of a product and let it make in another country. But if you put it into the market under your own name, you're the manufacturer. And as a manufacturer, you're responsible for the conformity assessment of the product, and you need to fulfill several legal requirements related to not only the CE marking, but also the traceability of a product. I've just summarized here the different obligations of a manufacturer. So as a manufacturer, you can only place conform products onto the market. You have to do the CE marking of the product, so the whole process that we described. You have to make the technical documentation and the Declaration of Conformity. You have to keep those for 10 years, but it doesn't stop there. You also have to make sure that you have procedures that to make sure that whenever you start producing that product in a series production, that every product keeps conformity. So what will you do to make sure that if you, for example, added for EMC a filter, that filter will always stay in your series production? What will you do that there's not too much variation onto the different products in your series production? Also, you have to do an identification of your products through a type, batch, series numbers. Contact details should be on the packaging or on a document accompanying your product. There should be instructions and safety information with your product. And whenever it would turn out in practice that your product would be non-compliant, given all the measures that you've taken, all the tests that you've done, you should take corrective measures. You should address and make sure that that product becomes compliant. And whenever asked for, you have to cooperate with the competent national authorities if requested. So you have to give them the technical documentation, you have to explain them what you did and why. As a manufacturer, you can also appoint on paper an authorized representative to take over some of the tasks that you have as a representative. That might be keeping the technical documentation available, keeping the Declaration of Conformity available, and cooperation with the competent national authorities if requested. What you cannot give to an authorized representative is actually the conformity assessment itself, because Europe says, well, as a manufacturer, know the product the best, so you're the best one to do that, and also not putting together technical documentation. Importer. What an importer is a natural or legal person who puts a product from a third country into the European market, and he gets actually the same responsibilities as a manufacturer. So that's also why I've put into brackets in the beginning the Declaration of Conformity, the word manufacturer. So an importer can only put conform products onto the market. He has to make sure that the manufacturer, the original manufacturer from that third country, has performed the conformity assessment, that conformity assessment was done according to all rules, that the CE mark has been attached to the product, that the technical documentation is ready and available, that serious numbers are available, and so on. Contact details of the importer should be on the packaging or a document accompanying the product. Again, instructions and safety information should be there, and if the product is non-compliant, the importer should take corrective measures, either himself or by contacting the original manufacturer. And of course, he also has to cooperate with the competent national authorities if requested. You can also have a distributor, so it's a natural legal person in the supply chain, different from the manufacturer or the importer, who offers a product onto the European market. He has to make sure that in all his actions he acts with due care to ensure that its handling of the apparatus or the equipment does not adversely affect the compliance of the apparatus. So he has to check if the product carries the CE mark and is accompanied by required documentation and safety instructions. He has to make sure that storage or transport does not adversely affect the compliance of the apparatus, and make sure that he takes corrective measures if he believes that the product is not compliant. Again, he has to cooperate with competent national authorities if asked for. So these are a little bit the different steps and the different roles that you have within the CE marking process. As a last section in my presentation, I will be illustrating this with the example of the EMC directive. It's also my main area of expertise. So this is just a screenshot of the first half page of the EMC directive here in English. If you want to read this document, it's very easy. It's freely available, so you can just download it. If you Google and look for the EMC directive, you will easily find it. It's available in the different languages that are there in the European Union. So you will also find a Dutch one, you will find a French one, but in essence they're all the same. And if you look for it, just make sure that you have the last version of it, which is the version of 2014, which has been actually active really from 2016 on. You will see it's a document of about, let's say, 20-25 pages, I think, but many things are very generic in there. So also description about manufacturer, the roles of manufacturer, the role of a distributor, and so on, what I've just explained before. And then only minor things, actually, I would say, or a small part of it is actually really related to the electromagnetic compatibility on its own. But to understand how the directive works, perhaps let's start with a definition of electromagnetic compatibility. And I've copied here the official definition from EMC as it appears in the International Electrotechnical Vocabulary. And there it stated that EMC is the ability of a device, equipment, or system to function satisfactorily in its electromagnetic environment without introducing intolerable electromagnetic disturbance to anything in that environment. And if you look into that definition, which is actually quite a whole mouthful, you will see that there are two different items here. At first hand, it's the ability to function satisfactorily in its electromagnetic environment, saying despite different electromagnetic disturbances. This is what we call immunity of a product. So if there are electromagnetic disturbances falling into your product, how will your product react? Will it always stay working? Will it not do anything very weird? Will it not fail? This is what we call immunity. And then there's a second part which states that you have that you cannot introduce intolerable electromagnetic disturbance to that environment, and that is emissions. How do electromagnetic disturbances go away, start from your product and go to the environment? And there actually you should keep that below given limits. If you will go into the EMC directive and you go through the first part, which is very generic, you will find the actual scope of the EMC directive. You will see here that it applies to all electrical and electronic appliances. It can apply to installations and equipment containing electrical electronic components. If you have a product which you say that it's not able to produce any electromagnetic disturbance, or of which the performance is not liable to be affected by such disturbances, it's not falling underneath the EMC directive. An old example was actually the example of an electronic watch. But as we're moving to more smart watches, you see again an evolution, that something that was in the past not underneath the EMC directive is actually now indeed underneath the EMC directive. Excuse me. And then you will also see that there is apparatus, like for example machines, that is covered by other directives. Machines is covered by the machine directive. They are not falling underneath the EMC directive, but you don't have to misunderstand that. It doesn't mean that you don't have to fulfill similar requirements as the essential requirements in the EMC directive, because again in that machine directive there will be essential requirements related to EMC, but you're not falling immediately underneath the EMC directive. Scope can be both apparatus, electrical electronic appliance, or also component. Can also be a fixed installation, something that is very large and that is being put at a predefined location, actually stays there. Think about a very large machine, a large network. Both things are falling underneath the EMC directive. There's a little bit a different way of handling them, but they both have to fulfill the same essential requirements. Then the most important part of the EMC directive are actually the the essential requirements. And this is then copied from that EMC directive. So the requirements are that equipment shall be so designed and manufactured, having regard to the state of the art, to make sure that the electromagnetic disturbance generated does not exceed the level above which radio and telecommunications equipment or other equipment cannot operate as intended. So this is the emission that we've just seen in our definition. And then that it has a level of immunity to electromagnetic disturbance to be expected in its intended use, which allows it to operate without unacceptable degradation of its intended use. This is again the definition of the immunity that we've seen in the definition of EMC. And this is actually the only thing that is there related to the essential requirements for the EMC directive. So there are no test methods, no levels or limits in the EMC directive. So these are very broad, generic requirements that don't change if technology changes, and then everything else is actually in the standards. And you have to go to the standards to see which test methods that you can use, which levels you can use, or which limits are reasonable for different products and for different applications. So how do you then go to prove that you actually fulfill the essential requirements of the EMC directive? There are actually 3 ways that you can use. Always start with the fact that you have those essential requirements for the apparatus. You start doing an EMC assessment where you identify which components can be more sensitive to EMI disturbances. What could be a worst case setup for emissions and so on? What would be the application area of your product and so on? And then based on that, you also go and look for which standards are there, which standards might be applicable to your product and your application. And the first way, and it's here at the right of my slide, is that you go for a full use of EMC harmonized standards, so that for all essential requirements, basically then immunity and emission, use harmonized standards. You follow those in all details, and you prove that you comply with those harmonized standards, you use that to make your technical documentation, and you put your declaration of conformity. So that's, from a legal point of view, the way of working that gives you most protection. So this is also the way where you get presumption of compliance. Of course, technology is going very fast. Also, standards are lagging behind. So for many applications, for many products, you don't have a harmonized standard. And that's why, of course, we also have to allow in this conformity assessment other procedures. And what you can do is a mixed EMC assessment, where you use for specific parts, specific phenomena, you use harmonized standards. But then for other things for which you don't find the harmonized standard, you use either new standards which are not harmonized yet, or use your own reasoning, your own test method, but you justify why you've done that. And again, you put your technical documentation, and based on that, you get your, or you can put your CE marking, and you can make your declaration of conformity. This way of working doesn't automatically give you the presumption of compliance, but if you have your technical documentation, if you can explain it, then it's of the, let's say, the same value as the first way of working. Of course, you could also have a very specific application, specific product for which you actually cannot use any of the applicable standards, and then you can even do it based on your own reasoning, do an own extended justification, make your technical documentation, and get to the declaration of conformity and your CE marking. So all three ways are allowed, but let's say the difference between them is the legal protection that they automatically give you. For all ways, you could involve a notified body, but unless you have a really high risk application, it's not really required as such. So you're free to do that or not. So again, a little bit repetition. EMC assessment, if you use harmonized standards, you give a reference to that harmonized standards, you have test reports, and then you get the presumption of compliance, but you don't really have to do that, or you're not always possible to do that. So then you can follow the no harmonized standards procedure, where you give a description of the equipment, intended use, and environment. You say why you cannot use harmonized standards, describe what alternative test methods you have used, justification of those methods, justification of the test levels, and then description of the EMC mitigation technique that you've used, shielded cables, filters, and so on, other considerations, test report, and then you can do the whole procedure. You can make your declaration of conformity, can put a CE mark, but you don't automatically get the presumption of conformity from a legal point of view. So an important part is also going and look for the standards. And here, what's important to know is that there's some kind of hierarchy in the standards. So if you look at the picture at the left, you see that we've talked about the directives, which are put in the official journal and give our essential requirements. And then you use these standards to really get the technical specifications to fulfill those essential requirements. And here you have, at one hand, the product standards, and that are standards that give the essential requirements really for a specific product. Then there are standards that are a little bit more broad and that give you the requirements for a product family. So that's more broad. And then there are even very generic standards which give you technical specifications for, let's say, more an application area. So if you look at a product standard, what could I say? It could be a product standard for a welding machine, for example, specific type. Product family standard could be for all, let's say, routers, for example, very broad. And then generic standard is just a standard that is saying, well, you're using that in a residential area or you're using that in an industrial area. Yeah. So those give technical specification, they give limits, they refer to test methods. And those test methods are not always described in detail in those product family or generic standards. Those test methods are then being described in basic standards. So they give the methodology to come to those test methods and to how you should prove that you're below a limit, but those don't necessarily give the limits. So those are in the product standards, product family standards, or in the generic standards. And actually, the way of working is that you should first look whether or not there's a product standard. If there's a product standard, it's preferred that you use that. If there's no such standard like that, you have to look for a product family standard. If there's no available there, you should go and look for the generic standards. Where should you go and look for that? Well, there's a web page from European Commission where you can find an overview of those standards. Also know that we as an institute give advice on that. You can go to, for example, Agoria and get advice on that. But is it a really hard problem if you didn't find that specific product standard, didn't know about it? Yes and no. Actually, you should know about it, but very often the different limits and methods, because they all refer to basic standards, are not that different. So in practice, there's quite large similarity between the different standards. If you then look, that's at the right, at the different phenomena that are related to EMC, you see that there are quite a large number of phenomena. So first at the top you see already the difference between residential or industrial environments, and then you get different phenomena for immunity and emissions. So for immunity you see there electrostatic discharge, CSD, radiant immunity, so that's immunity according to radiated waves that are falling in, electric fast transient surges or fast transients of different types on your main supply. Conducted immunity is disturbance falling in through your mains again. Magnetic immunity, voltage dips is the mains voltage that are falling away for a very short time. Or different phenomena that you have to, if it's applicable to your product, that you have to look at. For example, if you have a product that it's only battery fed, of course you don't have to do anything related to the mains immunity. Emissions, again, the same thing. You have radiated and conducted emissions. You have harmonic emissions. So what type of harmonics do you put into the mains? Flicker emissions. If you connect your product to the mains, will it make that a light will go and flicker so that people see it, and so on. So different types of phenomena, and then again for different products, the limits and test methods might be a little bit different, but very often they actually refer to the more generic standards that you see in this graph here. As the last part of my presentation, I'll just be showing a few of those phenomena, how we test them. I've taken out 3 of them. Radiated emissions. So what do we want to know is if you look at the electromagnetic fields that are radiated by your product, how much is that? And is that above some level that we seem to accept as non-acceptable? So it's EM disturbances radiated of equipment through openings, non-conductive materials, or connecting cables, which act as an antenna. And how do we measure it? Well, we put the equipment into an EMC chamber, so cage of Faraday, to make sure that we only measure the emissions that are coming from our product, to make sure that we have a more repeatable measurement. We also put absorbing materials, so the white and blue things that you see on the picture at the top right, we put absorbing material so that waves are actually absorbed and do not reflect, so that we only have the direct radiation from the product. That's what we call a semi-anechoic chamber. We use an antenna to measure the fields, an EMI receiver, and software. We do this from a frequency range of 30 megahertz up to 6 gigahertz in Europe, and even up to 40 gigahertz if you look at the legislation in the USA. So what do? We put the equipment under test, TUT, on a table of 80 centimeters high, which is on a turntable so that we can turn the UT. We have an antenna that we can move from 1 meter height to 4 meter height, and we just look for the maximum radiation when we start to turn the UT and when we start to move the antenna up and down. And then that maximum radiation should be below the limits that are specified in our harmonized standards. If you're below the limit, we pass. If you're above the limit, we have a fail, and we have to take corrective actions to get it below the limit. Radiated immunity is actually the opposite thing. So here we use the antenna to make disturbances to generate electromagnetic waves that fall into our onto our product, and then we see how the product reacts. So the setup is actually the same. We have our product on the table, again a turntable, so that we can move it in different positions. We put this in a semi-anechoic chamber to make sure that we really know what disturbance is falling in onto our product. We use a generator, an E-field meter, to measure how much disturbance we put there. And typically for applications, we talk here about a disturbance of 3 volt per meter for more residential areas and 10 volt per meter for an industrial environment. And here, if you look here to a pass or fail, it's not that simple as with radiated emissions. So radiated emissions are just below or above the limit. Here you can actually still choose what you say which is acceptable, and you have different immunity criteria. It's very important to also know that if you buy some CE-marked equipment, so you might have the situation, it's immunity criteria are that nothing happens, so it stays working like intended during the whole test. That's of course the best one. Immunity criterion B is that the device does something that is not really its intended behavior, but whenever the disturbance is taken away, the normal behavior is there again. Third immunity criterion C is that the product falls out. It's blocked, but when we take away the disturbance and we restart the product, it works again like intended. So it's not completely broken. Both or these 3 criteria can all be a pass in your immunity assessment. Of course, related to the risks that are there. If you are in an application where indeed it's critical that it stays working every time, then A is a pass and B and C is a fail. But if you have a more or a less stringent application, you can have A, B, C, all 3 as a pass. Yeah. The only thing, criterion D, which is that the product is really permanently broken, that's always a fail. But also important to know that if you look at the Declaration of Conformity and CE marking, there can be different things behind it, and it's quite important. Also, if you buy equipment components, that you really ask for, let's say, parts of the technical documentation that you really know what they have behind that CE marking. Last example is electrostatic discharge. We all know that from winter, where we get a shock when we touch our car or similar things. So it's an electrostatic discharge between person, object, and a product which creates it. It's actually quite fast and quite large pulse. And how do we test that? Well, we test that with using an ESD gun. We just mimics a person touching an object, and then we shoot with that ESD gun and that ESD generator at different points on our product, either by contacting it or through the air, where the ESD gun is still a little bit away from the product. And then we have different levels ranging from 2 kilovolts typically to even 15 kilovolts that we use to generate that ESD pulse. And again, we just look, it's an immunity test, so we look whether or not the product keeps on working related to the different immunity criteria that I've explained. So this is just very briefly a few of the examples of the tests that you should do. Then you have to explain in your technical documentation, your test report, what the outcome is of all these tests, and then if they're all a pass, you can complete your technical documentation and can put the CE marking onto your product. So this was actually in a brief overview of how CE marking and then apply to the EMC directive, how it works. This also ends my webinar. Just I want to point you to a seminar, 2-day course actually, that we will be organizing at the end of this month on increasing your product's immunity against electromagnetic disturbance in an approachable way, where we'll be explaining basic and advanced techniques to increase immunity against electromagnetic disturbances. So it's a 2-day course held at our campus in Ostend, and is given by Keith Armstrong, which is a very well-known teacher and consultant on everything that is related to EMC. And so the course is in 2 days. First day is more on the basic things about immunity, and then day 2 is more on advanced. Then we don't only cover how you should protect your product against different immunity or against different disturbances, but we also give you an overview of how you could if there's a problem, how you could solve it and figure out what is going on. And if you want to have more details about this course, feel free to contact either myself or my researcher, Tim Kleiss, at the contact details that are there below. So this actually opens the webinar for questions. So here you can also find all contact details. If you want to have more information about CE marking, about Impervol project, or about CDM. And I also already want to point you to the next webinar of the Impervol project, which will be held on April 6th, again at 10 o'clock, on virtual testing of an electronic system. Okay, thank you. So Bart, I'm available to answer questions if there are any.
Thanks a lot, Davy, for this nice and clear presentation. Before I will start the question and answer session, I just want to let you know that the webinars are recorded. Also, the slides will be available through the CEDM website. So you will get also soon this link through by email. So I will go over to the questions. So we got quite a lot of questions.
Mm-hmm.
The first one is, who decides which standards need to be included in the CE? Who decides in case of disputes? Googling for similar products may not always give correct results.
That's true. Well, to know who decides which standards to include and which not, you have to know a little bit about the way standards and definitely product standards are being made. So that's a whole international process where you have the organizations that were mentioned in my slide, like IEC, Senelec. They have international working groups, people that actually go and think about standards, and they make new proposals for standards, or they say we have to adapt that or that standard. And then they start up a whole process that might take a few years, where they make a draft of a standard, discuss it among that working group, and then once they have a draft that they are that they think is acceptable, this is distributed to all different countries, where again experts in those countries read that standard and are they can give comments on that. And for example, myself, I'm a member of different standard committees. I'm also a member of BC, CB. And so I get, for example, for all the things that I'm interested in, I get new proposals, drafts of standards, and I can give comments on that. And also as a company, I would advise you to try to link with those working groups and to know what is going on. Then of course, when the standard is there, then it's actually the European Parliament that says, well, on this or that standard will become a harmonized standard. So yeah, it's a very complex process, and I can imagine that it's not always easy to find all the standards that are applicable there. Who decides when there is a dispute? Well, that's a little bit a difficult question. I think it's then again it's a matter of what happens in the court. Yeah, I've also had a discussion with someone who is also in the discussion. When do you know that you've done everything that you should do? I think if there's a product standard, you can really rely on what the working group has done. Of course, you have to check that your product falls completely within the scope of the standard and within the intended application area. But when that is the case, I think you can say, from a legal point of view, I'm covered if I follow that. Otherwise, can you really claim that you've done everything? My feeling is not, but I also don't think that you really expect that you do that. You really more expect that you really do a good effort to do as best as you could do at that moment, given all the state of the art that is there.
Okay, thanks. The next question is, who has the right to demand a copy of the, I think, technical declaration file or documentation file? Sorry.
Certainly the all notified bodies and well the technical or the authorization, they can ask that. Yeah. Believe that's the case, but I would think if you have also want to have a good relationship with your customers, I would not always keep the technical documentation only for myself.
Yeah, and the second part of this question was, can a company refuse to make this public?
The Declaration of Conformity has to be public. I don't think your technical documentation as such has to be public. But of course, remember that everyone can probably do a complaint about your product, and then of course you will have to show your technical documentation to the authorities that are asking for it, or the notified bodies asking for it. Yeah. But I can understand that you don't want to share everything, and I also don't think that Europe expects that, because there are probably some sensitive things in there, or things that really give away the exact working of your product.
Okay. Next question: who may sign the EU Declaration of Conformity?
That's something that you have to decide within your company, and it's a person that within the company is accepted to be responsible for the whole process of doing that. So I don't think that there's a hard rule about that, but do remember that, like I mentioned, it's also a personal statement from that person. So it should be someone within the company that also within the company has a function that you say he's responsible for that whole process.
Okay, and the second part of this question is manufacturing outside the EU also acceptable then?
Yes, that's where you have to see. So I said that the manufacturer can be both someone who manufactures the product itself, or let it manufacture, and it doesn't matter where it's manufactured. If you bring it into the European market under your own trade name or your own name or trademark, then you're the manufacturer. It doesn't really matter where physically it's being made. It's the fact that you put it onto the European market that's important.
Okay. Next question is, when a manufacturer assembles several CE marked sub-assemblies into a new product, is a CE declaration of the product needed?
Yes.
Or is, yeah, so it's not sufficient to have the CE declaration of the sub-assemblies?
Not always. Perhaps for some directives it might be, but definitely, let's say for the EMC directive, it's not the case, because well, if you have different components, you have to attach them with cabling and things like that, and it's not because all of them apply to their own to the directives and they have the CE mark that the whole will be compliant. So it can also be in some cases that you use a component for which the product standard actually has a higher limit for that component than what you would have to fulfill on the whole product that you make from assembling different components. So also the essential the ERMANA standard, the limit that they give to fulfill the essential requirements of the same EMC directive might be different between components and the full product. And there again, why is that? That's a little bit because the making standards companies are also involved, and it's always a little bit a negotiation and lobbying, and sometimes there are things that make that some products get, if you would say, a more easy way to get the CE marking than other ones, and you just have to live with that. But so it's not because you buy CE marked components that the whole thing will be CE marked as well. So you have to really do that process again.
Okay. Another question is that this person understood that contact address in the EU must be on the product label visible?
I'm not 100% sure, but I do think that there should be one person in Europe that you have to contact, but I'm not sure. I'll actually have to pass perhaps this question to some people from Ahuria who might know this better than me.
Okay. Next question is ROHS, dus ROHS, already part of CE? Or do we need a separate ROHS declaration?
That also don't know. Perhaps part of, I think, perhaps some of your colleagues might know that. But as far as I know, it's just part of the CE marking. But I don't know if you also need to. Well, you probably need something in your technical documentation explaining why you claim compliance to that directive. But I don't know the exact details of it.
Yeah. And then next, quite long question. A comment related to the statement that EMC directive is not applicable to machinery since there exists a specific directive, machinery directive. Okay, it's more like a comment. Okay, I will forward the comment.
Yeah, but if I comment to that, what you very often see, and I actually also advise that, let's not take the example of the machine directive, but if you look at the radio equipment directive, if something falls underneath the radio equipment directive, it doesn't really fall under the EMC directive anymore as such. But the equipment directive does give EMC requirements, but what most companies do, and what you will see in most declaration of conformity, is that they still claim conformity to both directives and still do the complete work. And very often I just advise it because you still have to do it, and it's quite similar, so you can do that in that way.
Okay. Then about a question regarding space applications. So if the final product is flight, so before they used engineering qualification model, so normally it's all flight component inside. Do we need a CE mark for this model?
That's something that I don't know. I cannot answer that.
Yeah. And then still three questions to go. So there is a new safety standard coming up for IT equipment and audio-video equipment. So it's 6 to the IEC and then 2 numbers. When the standard is issued, do we need to create a new DOC for all existing products?
There's there's always a transition period. So whenever there's a new standard or a new version of a standard, you will see that there's an expiration date for the old standard and a starting date for the new standard. And the starting date of the new standard is before the expiration date of the old standard. So let's say that you have 1 or 1.5 years to indeed update your declaration of conformity. And as far as I understand, you indeed need to update your declaration of conformity according to the new standards. So that's also part of that market surveillance. And perhaps it was not clear enough in my presentation, but Europe do ask that you keep track of changes in standards and that you take corrective measures if, for example, at one point in time they would put more stringent limits onto it. But does it mean that you have to do the whole testing again? Depends a little bit on what has changed in that standard. Very often it are minor things, and very often it just might come to the fact that you have to change the date of that standard in your declaration of conformity. But it really depends on the application. But Europe does expect that you follow that, and that within the period of transition that you do that change, that you take care of that.
Okay. Second last question. So is there an easy way to be kept informed about upcoming updates of harmonized standards?
But the best way, like I mentioned, was to get involved with the national organization that is related to all that standardization, so the CEB. And otherwise, you should get into contact with organizations like Ahuria, and they keep track of those things as well. And every year there's for every directive, Europe publishes a list of harmonized standards. But if you only follow the harmonized standards, I don't think you have everything, because very often there are new standards being made which are not yet harmonized, but which you can use if your product falls within that particular scope. So yeah, it's a little bit, yeah, my feeling is that if there's a standard that really is for your product, but it's still not harmonized, it's very useful and probably well, preferred to use that, or to at least have a look at that standard, what they ask for.
Okay, and then the last question, which is a more technical one, relates to your examples at the end of the presentation. How to submit your device to EMC test if it has different operating modes, such as normal sleep, deep sleep modes?
Well, the way that, or what the legislation prescribes, is that you should do within your risk assessment an analysis of what would be the worst case situation or worst case operation mode. It's a very difficult question, and it's one of the things where I said that you can never really prove, definitely not for the EMC directive, that you have full compliance with the essential requirements. There will always be some modes that you're missing during your testing, so you cannot cover that all, but you have to do a reasonable effort given the cost and the time that you need for testing. Just to give an example, that has been a discussion within the general working groups discussing on EMC, for example, for televisions, when new types of televisions came out a few years ago with the new types of screens. Typically that is tested with the TV working as normally, but then in a few occasions one had noticed that the emissions, I believe, were higher if the television was in the sleep mode, in the standby mode. And then you did see in a few documents the suggestion that for that specific type of televisions with that specific type of screens, it was really recommended to both do the normal working and the standby mode. So again, I think for you should do more or less an assessment. I know it's quite difficult to know that upfront, and then do a reasonable effort to cover most of the situations that you could do in testing. But there's quite often not a hard rule, except in a few product standards about what all you should do. It's left a little bit to responsibility of the manufacturer.
Okay, I think now we can. This was the last question, so we can conclude here the webinar. I thank all the attendants for participating to this webinar. You see here the contact addresses, so if you have still some questions regarding the presentation or the project, or in general to the CEDM, the Center of Electronic Design and Manufacturing, then you can contact us. And just as Dave already mentioned, so the next webinar is in 2 months from now, and we'll deal about virtual testing of an electronic system. Thanks a lot, and have a nice day, and I hope to welcome you in the next one of the next webinars. Okay, bye.
Okay, thank you, Bart. Bye.